Hello everyone, I'm Paul and today we're solving problem 3217, delete nodes from the linked list present in array. This is medium and next I will show you how to solve this efficiently. I would say this is a coding problem because the description is simple. The logic behind this is very simple. We are given an array of integers nums and the head of a linked list. So let's say this is nums, this is the head of the linked list, and we need to return the linked list after removing all nodes that have a value in nums. So for this example, given that this is the array nums, we need to remove 1, 2, and 3, and we return this linked list. And the main issue here is that we need to check if we have each of these values in nums efficiently. And for this, we can use a set. Remember that in sets we store unique values and we can do lookups in big O of 1 time complexity. So we have a set with every value in nums, 1, 2, and 3 in this case. And there are at least two ways to solve this. One is we can iterate this linked list from left to right, and whenever we find a number that's not in the set, we add the corresponding number to a new array. We can call this result. So first we are here and 1 is in the set, so we continue. Next we are here, we have 2 here, next we are here, we also have 3, next we are here. Even that we don't have 4 here, we add 4 to the result. Next we are here, 5 is not in the set, so we add 5. And once we have this array, we can build a linked list from scratch and return the corresponding linked list. I will leave that solution to you because I think it's very intuitive and it's not very efficient. So here we will code a different solution. What we are doing instead is we are iterating this linked list and we are skipping nodes whenever it's necessary, and we are returning this same linked list after removing these nodes in this case. Let's say this is nums, we only have a 2, so we have a set with 2. And we are standing here. And we know that the next node is a 2. And we have 2 in our set, so we need to remove this. The question is, how do we remove this node? Well, let's say that this node is current. We'll say that current.next is current.next.next. And by doing this, we are removing this edge and we are creating a new edge from 1 to 3. And this is as if we remove this node. So after doing this, we can return the new linked list without the 2. So this is very important. So with this in mind, let's go with the code and hopefully you will get the idea. First, we need to build a set. So we are building this from nums. And now we want to remove the first nodes until the first node is not in nums. So we can say while we have a head and head.val in the set, head is head.next. And now we can say if after doing this we don't have a head, return none. Now by doing this, we are making sure that the first node is not in nums. So now we can say current is head, and while current.next, if current.next.val is in the set, meaning we need to remove this next node. Remember how we remove nodes. We say current.next is current.next.next. Else, if we don't have to remove the next node, we just say current is current.next. And we are using current to update the linked list. And finally, we need to return head. Remember, we return head instead of current. Okay? So this is the entire code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. Here, time complexity will be big O of m for the length of nums plus n for the length of the linked list, and space complexity big O of m. So this is it for this problem. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.